When you're dealing with angles on the Cartesian plane, until you get really good at this, I'm going to encourage you to just draw it. It makes it way easier to see what's going on. You have to memorize less, and eventually you'll be able to do away with that crutch. Here we're asked to find the tangent of the angle 2 pi over 3. So before I even do that, I'm going to go ahead and just graph the angle 2 pi over 3. So one of the things that I find useful is, well, 0 is just 0 no matter what, but my angle is 2 pi over 3. Now, I do know that that's less than 1 pi, but wouldn't it be a lot easier if this pi over here had a denominator of 3? Well, 3 over 3 is 1. I know that's equivalent to 1 pi. So now I can make a comparison between this half revolution and 2 pi over 3. I know that it's just going to be pi over 3 short. Pi over 3, I know, because I've memorized it, and I'll encourage you to do the same, is part of a 30, 60, 90 triangle. So I'm going to go ahead and draw my triangle. You'll notice that I made this array here, so I can make this point out as far as I want. Again, the size of the triangle doesn't matter. I'm going to go ahead and choose my hypotenuse to be 1 though. Now I know that pi over 3 is part of a 30, 60, 90 triangle, and that the other angle is just pi over 6. I encourage you to kind of memorize that, but you can take my word for it for right now. Now the key to this is I know that I need to know which one of those is the bigger angle, because that'll tell me where the biggest side of my 30, 60, 90 triangle is. Well, if I take the same value and I divide it into a smaller number of pieces, I'm going to have more. Take a pie, you divide it into 3 slices. Those slices are going to be bigger than if you divide it into 6 slices. So what that tells me is that my reference angle, pi over 3, is opposite the bigger side, which I know in my unit circle values is just the square root of 3 over 2, and y is positive in this case, leaving my x value to be -1/2, because x is in the negative direction here. So now I have my coordinate, and I know that tangent is just equal to y over x, meaning that it's just equal to the square root of 3 over 2 over -1/2, which, doing that division, I know is just going to be negative square root of 3. The last little check I usually do is I double check using my acronym, all students take calculus. And we're in the second quadrant here, so sine is the only ratio that's supposed to be positive, and tangent should therefore be negative. This is just one example of what values you might need to find when you're dealing with trig functions, angles, and coordinates. However, what I really wanted to illustrate here is that those things are all combined together into graphs like this. So as much as possible, I encourage you to graph these out and get a picture of what's going on, because it gives you all the information you need.